Now we're looking at question 9, and it has that the diagram shows a circle where AC is a diameter and BD are two other points. All right, it tells us that BD are two other points on the circle and DC is a straight line. So this is one straight line, we'll know that. And they tell us that angle CAB is 28 and angle DBC is 46 degrees. So because I give an angle CAB and DBC, all right, now let's look how we're going to decipher this now. Now, looking at this now, what it looks like is triangle ADC. DC is a straight line, and so this is a right angle triangle. Triangle ADC is a right angle triangle. So triangle ADC is a right angle triangle. Triangle ADC is a right angle triangle. All right. Now, if triangle ADC is a right angle triangle, what does that tell us? And if triangle ADC is a right angle triangle, the next thing we know is that ADCB is a cyclic quadrilateral. So we're not answering the question yet, we're just writing down what we know. ABCD is a cyclic quad. All right, so ABC forms a cyclic quadrilateral. ABCD is a cyclic quadrilateral. Now, if it's a cyclic quadrilateral, then what we know is that this angle, then we know that the angle at A plus angle at B plus angle at C plus angle at B is equal to 360. And we also know that the angle at A plus angle at C is 180, and the angle at B plus, there it is. Because it's a cyclic quad, the angle at B plus the angle at D, which is 90, is going to be equal to 180. All right, this is equal to 180. And so now, but the angle at B is two angles. It is, let's call this theta plus 46. So we have theta plus 46, and 46 plus 90 is 46 plus 90 is 136. So theta plus 136 is 180. And if theta plus 136 is 180, then theta is equal to 44 degrees. Theta is 44 degrees. So theta is 44 degrees. That's angle DBA. Angle DBA is 44 degrees. Whoa, that was a little bit nice. All right. And now, of course, it always asks to give a reason for your answer. So of course, you're going to tell them triangle ABC is a right triangle. And so hence, but don't even say hence, also ABCD, the quadrilateral ABCD forms a cyclic quad. Also, the quadrilateral ABCD forms a cyclic quadrilateral. And so, since it forms a cyclic quadrilateral, and so the angle at D, so the angle at D plus the angle at B in the quadrilateral ABCD, in the quadrilateral ABCD is equal to 180. So that's the reason that we used to solve for this for theta. All right, easy question. All right, now next it asks for angle BAC. Angle BAC. So let's look how we're going to find BAC. Angle BAC. So this angle we want, I'm going to call it Y. Let's see how we can find Y. We know this is 90. Now, if I were to call this point, if I were to label this point as, I don't know, I would label this as, let's call it X. Now look at this, I'm just labeling the point as X. Now what I know is that this angle is equal to this angle, and this triangle is similar to this triangle. Can we see that they're similar triangles? And so this angle is also going to be 28, and this angle is also going to be 44. This angle is also going to be 44. So this angle right here, which we don't really need to know, but we know that theta is already 44. So this angle is actually 108. So this angle is 108. 108. And so that angle is also 108. This angle is 108. All right. Now that we know that this angle is 108 and this angle is 108, then we already know this angle. We know this angle. Now, how do we know this angle? Because this angle and this angle will be the same. And so this angle is going to be, if this is 108, then this angle is 360 minus 2 times 108 divided by 2. So this is 72. This angle is 72. If this angle is 72, then this angle, as we know, is 70, because 70 plus 20 is 90. This is 70. I know it's all jumbled. I hope everyone's following. This is 70. So this angle is 180 minus 142. All right, I know it's all confusing, but we're gonna look at it now. This angle is 180 minus that. So angle DAC, which I call Y, angle DAC is equal to 180 minus, that look like 70 plus 72, minus 70 plus 72, 70 plus 72. And so what am I getting? That angle DAC is equal to 180 minus 70 plus 72, that's 38. It's 38, that's angle DAC. Angle DAC is 38 degrees. And what's the reason? Something's off. This is 90. Let me see that. 90 plus, if this is 44 plus Y, when I add them, I'm not getting back 180. I'm saying this is 70. This is 72. (108) plus 20 plus 44. Oh shoot, snaps. If this is 20, this is not 20. My handwriting is so bad that I got thrown off. This is not 20. All right, so let's clear this up. My handwriting is so bad it confused me. So my apologies, guys. I made a mistake. My handwriting got me thrown off. So this part we know is 44. All right, let's go again. This part is 44. Now that we know that this part is 44, no confusing anymore. This is 44. Then we know this angle, which we don't need to know, but it's good to know. Now if we know this angle is 44, then we know this angle as well. Because angle in a triangle sum to 180. So this angle right here is 44 plus 28. 44 plus 28. This angle, 44 plus 28. This forms a triangle. Angles in a triangle is 180. That's 72. This is saying 108. And 46 plus 44 plus 28, that's 118. So this angle is 180 minus 118, which is 62. So this angle right here is 62. That angle is 62. Now if this angle is 62, then we know this angle. That angle is going to be 180 minus 46 plus 62, which is 72. So this angle is 72, and this angle is 108. So this is 108, and this is 108, and this is 72. And so this is also 72. All right, this angle is also 72. This angle is also 72. And if this angle is 72, we already know that this is 90. And if this is 90, and we already know that this angle is 28, aha, this angle is 28, and this angle right here is 62. 62 plus 28 gives us 90. So now we know what this angle is. This angle is 180 minus 62 plus 72. 62 plus 72, 180 minus that. This angle is 46. It's the same as this angle. It's 46. All right. So this should be 62 plus 72. So it is 46. 62 plus 72, which is 46 degrees. Nice and easy. You just have to be very careful with your addition sometimes. As you can see clearly, I added one thing incorrectly and it thrown off the answer. So this is 46. Have to be very careful. All right, now the reason, well, look how many things we did for this, so many reasons. We can say that triangle, I'm going to label this point as X. And so triangle AXB is similar to triangle BXC. So that's my reason. I'm going to write that. So triangle A, what did I say? Triangle ADX is similar to triangle ADX, because I label this point as X. Triangle ADX is similar to triangle A. Triangle ABX. Triangle ABX is similar to DXC. Triangle ABX triangle ABX is similar So triangle A, it's similar to triangle A. BX is similar to triangle XDC. XDC. It's similar to triangle XDC. All right, so because they are similar triangles, hence they have similar correspondent angles. All right, that's one way to do it. All right, nice and easy. And so now the next part of the question is asking for angle BCE. Please find BCE. Angle BC, where's E? Oh, angle BCE. So angle BCE is this angle. Let me put it in blue. This is angle BCE. Now, first and foremost, we already know this angle. Because this angle is 62. We know this angle is 108. So this angle right here is 108 plus 28. We say 180 minus that, that's 44. So the angle that we want is 180 minus 44 plus 62. So this is equal to 180 minus, in bracket, 44 plus 62. And the reason is because angles on a straight line sum to 180. Angles on a straight line sum to 180. That's the reason that we're using. So we work that out and we get 180 minus 44 minus 62. So that's 74 degrees. And the reason again is angles on a straight line sum to 180. Angles on a straight line sum to 180 degrees. That's nice and easy. Angles on a straight line sum to 180. And we finish with trigonometry. Well, we finish with geometry. So now we're going to look at this tricks question. All right, now looking at this tricks question, it's very simple. Nothing hard at all about it. It says, the diagram below, you want quadrilateral PQRS, where PQ and SR are parallel. Angle SPQ is 90, SQR is 82, and QSR is 30. Find the length of PS. Find the length of PS. Now, there's so many ways to find the length of PS, but PS, this right here. Now, this corresponds to this. Now, look at this now. If this angle is 30, then this angle is 60. This angle is 60 degrees. All right, so this angle is 60 degrees. All right, and then if this angle is 60 degrees, then this angle is 30, because angles in a triangle sum to 180, so this angle is 30. So I'm going to use sine rule to find PS. So using sine rule, we can say that the sine of 30 over PS is equal to the sine of 90 over 8. All right, so that's what we can do. We can use that over the sine of 90 over 8. So now we cross multiply and do what we have to do, and we're going to get that PS is equal to, make PS the subject, we're going to get PS is equal to 8 sine 30 over sine 90. PS is equal to 8 sine 30 over sine 90. That is PS. So when we work this out, 8 sine 30 is 8 times a half. 8 times a half is 4. And the sine of 90 is 1. So PS is 4. PS is 4. That's one way to do it. Another way to do it is using the regular boring trig ratios method. So the boring trig ratios method would tell us, since we know this angle is 30, or we know this angle is 60, then you could call this the adjacent if you want. And some people would go further to say the cos of 60 is equal to the adjacent PS over the hypotenuse of 8. And so if you wanted to use that method, then you get PS is equal to 8 cos 60. Depends on which way you want to use it. All right, so if you want to use sine rule or you wanted to use regular trig ratios, you still get the answer being 4. 4 what? 4 centimeter. I like sine rule. So PS is 4. Now that we find that PS is 4, it asks for PQ. Given that it has 1 mark for PQ, let's just use Pythagoras Theorem. So Pythagoras Theorem tells us that 4 square plus PQ square is equal to hypotenuse square. So 4 square plus PQ square is equal to the hypotenuse square, which is 8 square, which is 64. So what we're getting then is PQ square is equal to 64 minus 4 square. 64 minus 4 square, that's 64 minus 4 square, that's 48. And so PQ is the square root of 48. That is the length of PQ. PQ equal the square root of 48. So it didn't ask us to simplify it. So you could just write the square root of 48 centimeter. It didn't ask us to simplify it. All right. Now it asks for the area of the rectangle, the area of the quadrilateral PQRS. The area of the quadrilateral PQRS is just going to be equal to the area of, I want to say the area of this triangle, area of this triangle plus the area of this triangle. Yep, that's how I'm going to do it. All right. The area of this triangle, half base times height, plus the area of this triangle, half AB sine theta. We have one side, so I need to find another side. All right, so all right, so that's another way to do it. So what I'm going to do here now is we have one side, right? We need another side over here. I'm going to find what is SR. All right, now SR corresponds to this angle. All right, so what am I saying? What I'm saying is the sine of 82, the sine of 82 over SR, the sine of 82 over SR is equal to the sine of an angle over 8. So this is what I'm going to use to find what is SR. Now the sine of what? Now this angle, 8 corresponds to this angle. And this angle is 80 plus 30, 82 plus 30 is 112. 180 minus 112 is 68. So this is 68 degrees. So if that is 68 degrees, and this is sine 68. So continuing now, I'm going to transpose to get SR. And so working for SR, I'm going to get that SR has to be equal to, all of this is going to be sine 68 over 8. Sine 68 over 8 is 0.115. And so making SR the subject is, SR is going to be equal to sine 82 over 0.115. Sine 82 over 0.115. That gives me SR. And that gives me SR to be 8. It's telling me SR is 8.5. SR is 8.55. Now that I know that SR is 8.55, I'm kind of good. Right? SR is 8.55. Knowing SR is 8.55 make everything easy. And you might wonder why. Because the area of this thing is the area of this triangle plus the area of this triangle. All right, so the area of this triangle, I'm going to do it in black for the first one. The area of the first triangle is a half AB sine theta, or maybe a half base times height. The area of that triangle is a half the base times the height. So it's a half of 4 times the square root of 48. And that gives me the area of that triangle. And then I'm going to know the area of this triangle using half AB sine theta. So the area of this triangle in here, the area of this triangle is equal to a half 8 times 8.5 sine 30. All right. So now I'm going to find the area of the quadrilateral. So the area of the quadrilateral in total is equal to the area of triangle PQR is equal to the area of triangle PQR, area of triangle PQR plus the area of the triangle SR something plus area of triangle SRQ. So we're going to work these out now. We already worked out this one, the area of triangle PQR. We work it around here. Area of triangle PQR. That part was going to work out to be a half of 4, which is 2. 2 times the square root of 48, which is 13.9. 13.85 to be exact. And then we need the area of this part now, which is a half AB sine theta. Area of this part is going to be a half AB sine theta, which is a half of 8 times 8.5 times the sine of 30. A half of 8 times 8.5 times the sine of 30. That's going to give us the area of this triangle. All right, so let's work out this one. What we're going to get from this one is a half 8 times 8.5 times the sine of 30. That is 17.1. So this works out to be 13.86 plus 17.1. 13.86 plus 17.1. And then I add them together to get my final area. And my final area is 30.96. And remember, area is centimeters square. Area is centimeters square. Easy. Nice.